Hey everyone, geophysicist Stefan Burns. We have just had another X-class solar flare on the sun today, June 19th. This time a 1.9 X-class flare, a massive solar explosion, as you can see here with our 131 angstrom imagery. And this is getting really interesting. We just had a X-class flare on the 17th of June. This was a 1.2 X-class flare. There are 5 different classification levels for solar flares. Basically these massive explosions on the sun. Okay, now the 3 highest are C-class flares, then you have M-class flares, and then you have X-class flares. Each time you go up a classification, you go up an order of magnitude in the energy released in the X-ray part of the light spectrum. Of course, these solar flares also release visible light, ultraviolet light, extreme ultraviolet light, but we classify them with the X-ray light because that is the most variable in its output, going from, let's say, quiet conditions to a giant explosion. So the X-class zone is the strongest classification of solar flares. We've had now 2 in 48 hours. And what's so interesting about these 2 solar flares is the fact that they have both directly hit Hawaii with their light photons. So they've been radiating effectively the entire Pacific Ocean, because when it's noon at Hawaii, the Hawaiian Islands, then effectively the entire Pacific side of the Earth is facing the sun. This emits all this light radiation. 8.3 minutes later, boom shakalaka, that hits, charges up the ionosphere, creating a bunch of plasma, really strong electric fields, electric currents, strengthens that global electric circuit, that flow of energy from the ionosphere to the ground surface. And we know that traveling ionospheric disturbances are connected to earthquakes. We also see volcanoes. Sometimes they explode. There's volcanic lightning. We know that lightning is modulated by the global electric circuit. That atmospheric conductivity sometimes raises up dramatically, orders of magnitude before and during an earthquake. So we see that volcanoes and earthquakes are really connected to the global electric circuit, and that flow of energy from the lithosphere through the atmosphere to the ionosphere, which is about 1% plasma, starting about 50 kilometers up, but really dense at about 300 kilometers above the surface. And these sort of solar explosions blast the ionosphere with a ton of energy. And now we've had another one just as we've been forecasting on the channel. Hello and welcome. I'm your host, Stefan Burns. What we cover on this channel is the connection between solar activity and, for example, weather here on Earth in the troposphere, like thunderstorms and lightning. I'm in Greensboro, North Carolina. We're about to go to Cosmic Summit, where we talk about all these sort of crazy things: comet impacts, super flares, ancient history, and we just had a thunderstorm roll through. So these sort of dynamics are amplified, like big thunderstorms or cyclones, volcanic eruptions, earthquakes, when we have significant solar activity. And they are expecting Hawaii to begin a new eruptive episode, specifically at Kilauea Volcano. And USGS is forecasting that is going to start basically anytime now through the 20th, based on the uplift rates. So very interesting that the last eruptive episode around the 11th was one of the biggest that we've seen. The lava fountain about 1,000 kilometers high. Really wild stuff. Check it out. This was the last one, episode 25. These are all the same lava fountain, by the way, okay? Just different perspectives on it. But massive, massive eruption of magma there. And now we're forecasting that episode 26 is going to begin right after we get these back-to-back X-class flares smacking into Hawaii with their light photons. So really exciting update for you. We're going to do a complete space weather report, as well as look at some of these Earth terrestrial geophysical factors. And just in general, hope you're all doing well. These sort of solar flares can be very taxing on the body physically, mentally, emotionally, but they also provide a lot of opportunity, you could say, because when we get this big burst of light radiation from the sun, this in general kind of activates the metabolism of the body, and so you have more energy to do things and to, let's say, work on your creative passions or pursue a goal or a project. So, or even just like to exercise. I notice if I go to the gym, When there's a lot of solar activity, I'm like stronger, I'm fitter. So we have not only these Earth terrestrial effects, but we also have our own physical effects. And there's also the larger collective effects about how solar activity influences, for example, spontaneous social processes, aka like revolutions. People sometimes act a little crazier when there's high solar activity, like solar maximum, which you're in right now, solar cycle 25. In general, everything just gets amplified. Our entire reality is light-based, effectively, because all our sensors are light-based. So when the sun decides to blast off a massive solar flare, you can expect that is going to affect us. And happy solstice. It is solstice tomorrow, June 20th. In the northern hemisphere, this is when we have the most amount of light. In the far north, they have 24 hours of light uninterrupted. They already have that right now, but tomorrow specifically is solstice. And so this in general is that moment where light is at its greatest extent, and there's just the sheer abundance of light, and then summer begins. So very fitting that the sun has been blasting off all these extremely powerful solar flares as we approach solstice. In fact, this is what we've been forecasting based on planetary geometry. But before we talk about that a little bit, let us look at our 284 angstrom view of the sun, because this is kind of wild. Check this out. This is really, really cool. And so I don't often show this angstrom view of the sun, but we're looking at it today because it shows two plasma filaments really clearly. And actually it's multiple plasma filaments, but look at this. We have these plasma filaments traveling basically directly to our sunspot group. Look at this one, stretching all the way from the other side of the sun, snaking its way like this directly to our area of greatest flux. This really big sunspot group, 4114, which has been flaring significantly. An 8.5 solar flare, a 6.4. These are both M-class flares, and then this 1.2 X-class flare, and then this new 1.9 X-class flare. But these tendrils are snaking there, and perhaps are feeding energy to this sunspot group from the far side of the sun, or just in general, there are these large electric flows of energy across the entire, basically this very large part of the circumference of the sun. This is important because of the planetary geometry that we have active at this moment in time, or at least it could be important because of that. So let me show you the planetary geometry really quick. Boom shakalaka, 1.9 X-class flare. I've had a long travel day to get here to Greensboro for Cosmic Summit. Excited to meet some of you at Cosmic Summit, but I am pumped up and ready to go. This is exactly the sort of thing that it's all about. So here we have our solar system. This is an application called Solar System Scope. And we're looking at the planetary geometry for today. The angles between the planets and the distances between them are accurate. The only thing not accurate here, for the most part, is like the scale. You know, the scale's off. But we're looking at the scaling here in kind of the not realistic one to make it just a little bit easier to see everything. If I put this on realistic scale, it makes like no sense. So here we have our planetary geometry. Here is what's happening in just a few days. Jupiter Cazimi. We have the Earth right here going through its orbit. We see Jupiter also moving through its orbit. It's on the other side of the sun. If we go back to the 25th of June, we see Jupiter on the other side of the sun exactly. If we go back to the 24th, you'll see that we have that new moon right here. So check this out. If we go there, we have our moon in front, and there's the sun, and there's Jupiter. So the 24th, 25th is a power-packed energy time, but we're already approaching the critical planetary geometry I've been discussing since May 29th. We've been forecasting enhanced, like greatly enhanced solar activity for this time frame of like June 19th all the way through the end of the month since May 29th based on planetary geometry, and in general this understanding that we're in solar maximum. You know, we've been tracking sunspots, things of this nature, but it's been mostly planetary geometry. The viewers that have been here for a while, you guys know this. We've been using this for months now, very, very accurately. So it's time that all the other space weather forecasters catch up. Like really, it's time for them to catch up because this is serious business. But we'll notice the other planetary geometry is active right around solstice. Here, Mars and Mercury in alignment there on the eastern limb of the sun solar coordinate system. Jupiter on the far side, exactly 180. And then if we look off to the right, this is the western limb of the sun right there. Saturn and Neptune about to perform their historic conjunction once every 35 to 37 years. The two of them meet up in the night sky. That's a pretty big deal. And so we see this grand cross. See that right there? Like this. We have this grand cross set up. There's also a grand trine in this symmetry and also a kite formation. So there's quite a lot of really notable planetary geometry. You can see the grand trine right here. Pluto, Uranus meeting up with Mercury, Mars like this. This is heliocentric planetary geometry. And then the kite formation is the fact that we have Pluto basically forming this sextile 60-degree angle to Saturn and Neptune, which Uranus is also doing. Again, we have that Mercury, Mars there at the bottom of the kite. We are squared to it, and you'll notice that the Earth is kind of like off on this other side of the dish, you could say. It's like the one planet other than Pluto, but it's really the one planet holding up that part of the square. Jupiter's the biggest planet in our solar system, so it can hold its own square, that side of the square, pretty easy, right? Mars and Mercury together are holding up one side. You have Saturn and Neptune holding up the other side. Earth here is like by itself, holding up one entire side of this square. Perhaps that's why we're getting blasted with these solar flares, and it's really hitting Hawaii. Let's check out our Hawaii live stream, because we do have a live stream from the USGS, and it's not erupting yet, but first let's just see what they have to say. Episode 26, lava fountaining, will likely begin between June 18th and the 20th based on current rates of summit inflation. The forecast window may change as new data comes in. Fountaining could be preceded by hours to days of precursory activity. So they are expecting Kilauea to erupt basically in the next 24 hours, though again that could change. Here is their live stream that's really punched in on the zone of greatest fountaining thus far and some of the inflation, and you see that smoking right now, but we've had two direct hits over Hawaii now in 48 hours. And so I suspect that we're going to see some sort of response from Hawaii. The lava fountain's basically been getting bigger each time. Last time, again, going up 300 meters, 1,000 plus feet, which is insane. It's not like Hawaii is going to explode and create a volcanic winter. At least we don't think so. We don't have evidence for that. The lava is very mafic. Mafic. It's very mafic. It says low viscosity, so it just kind of spills out like this. But still showing that there's a lot of energy underneath the Earth coming up. Basically, the big hot spot in the Pacific Ocean, that is Hawaii. We have our D-region absorption map to show this direct hit over Hawaii. Radio blackouts now, significant radio blackouts effectively as a result of these X-class flares. That is actually what this planetary geometry forecasting method was originally developed for. It was for figuring out when there would be radio blackouts for radio frequency communication, and you also do get those during geomagnetic storm impacts, but you get them from solar flares as well. Big explosion on the sun, 8.3 minutes later, you get an increase, you get that those light photons to hit the Earth, and then you get the plasma of the ionosphere to start oscillating differently, and that degrades radio frequency, and so you have to change your bands to different frequencies in order to communicate. Generally, you have to raise your frequency up. But we'll see this flare hit Hawaii just about now. This is noontime effectively for Hawaii, and then here it goes. Give this a watch. There's that R3 radio blackout. Boom, nearly directly over Hawaii. Let me show you the last solar flare, and we'll discuss the times, that 1.2 X-class flare, because I just find it really interesting that we've had two X-class flare nows, the only two X-class flares in a while, back to back in 48 hours, smack dab hitting Hawaii. I just think that's interesting. Now, if you get 3 of those in a row, then there's something definitely happening. But as it is right now, there's only 2 of these in a row. Here is the first R3 radio blackout over Hawaii. Let me turn this on for you. And here we go. This is a screenshot, so it's not the video, but we see that's directly over the big island, the island chain. This was the peak X-ray flux for this 1.2 X-class flare on the 17th of June was at 2149 universal time. And this X 1.9 flare today was at 2350 universal time. And I think Hawaii is going to put on a spectacular show with its next fountaining episode. So here's the 1.2 X class flare, here's the 1.9. The 1.2, 1.9. Both of them nearly directly over Hawaii, only about an hour different in time, and all happening around solstice, this natural energy pulse moment for the Northern Hemisphere where we just receive a lot of light radiation. So exciting stuff, really exciting stuff. I think the planetary geometry is proving itself to be very, very accurate in terms of forecasting space weather. And I think factors like this right here, where we have these incredible plasma filaments on the sun reaching back to the far side of the sun, both this one and this one feeding into the sunspot group, helps us to have a scientific understanding of how this works, because Jupiter is the largest planet in the solar system, contains most of the rotational velocity of the solar system because it's rotating extremely fast on its axis, and it's a plasma heavyweight of the solar system. It's a massive plasmified planet. Not only Jupiter itself, but it also has, for example, the moon Io in its magnetosphere, and the torque of Jupiter, its magnetic field, and its gravitational field on Io causes it to have these basically continuous volcanic eruptions, and therefore that puts a lot of plasma into Jupiter's magnetic field and into the plasmasphere, which it then accelerates and spews out all across the solar system as Jovian flux. So it has these really interesting energetic dynamics where it uses its moons as plasma generators, and then it shoots that out across the entire solar system. Well, we're now in that planetary geometry where we have Jupiter here, Earth there, and then on the other axis, Mercury, Mars, Saturn, Neptune. So all the planets effectively are working in this. They all are, again, Uranus and Pluto in a trine and kite configuration, but all the ones I just listed were in that square configuration. So it sounds a little bit like madness until you learn it. I will admit, until you learn this stuff, it just sounds like a lot of madness, like this, that, but it is really fascinating stuff, and that is what I go over on this channel in depth. And so if you watch the channel more than once, you will start to make sense of this, because I explain as I go. I think education is the most important thing, and I think learning to do your own research and make up your own mind on things is very important. I'm really just a communicator and messenger here, a messenger for the sun. Here we have our latest space weather model by NOAA, and we see this coronal mass ejection launch out from the sun. Expected impact, guess what? Tomorrow on solstice. So we see this launch here, and this is looking down on the sun and the Earth. This is the ecliptic plane. We see most of it going to the north there, but we do get grays there to these just a little bit by the flank. The original model of this basically had this not really hitting us. But then they finally re-examined the coronagraph imagery and said, hey, okay, this looks like it is going to hit us. So it took longer than they originally forecast, but the original forecast was way too fast. And now it looks like we have this solar storm coming in tomorrow. And if I pause this exactly on the time of impact, let's get that lined up. Let's just say it's right there. That is at 4 a.m. Universal Time. So on the 20th, we are just a couple hours away from that right now as I'm filming this live. So yeah, I mean, right now it's 1:52 a.m. Universal Time on the 20th. So this solar storm impact from some other solar flares and explosions that launched earlier, that could come in very, very soon. That could come in just a couple hours. It could come at any moment now, basically. It could also miss us, but we had a nice signature on that. 2 solar storms, in fact. I can pull up that video quickly just so you can see it, because we are likely going to have a geomagnetic storm tomorrow. They're forecasting a G1 storm. Could be more than that though. We'll have to just wait and see. But let me show you this differential imagery here. And you can kind of see what we're talking about. So here we have our chronograph differential imagery. We are seeing some stuff launch out there already. Let us, okay, yeah, so, so you'll watch two, okay? You're gonna see one go up here like this, that's the first one. And then here's the second one like that, and they're both partial halos. Most of it going to the north, but some of it definitely interacting with us. Let me slow this down. This is a little too fast for us for quality purposes. If I can slow it down to 50%, you're gonna watch this first one, definitely fainter than the second one. Launch most of it to the north, but watch how it spreads out to the right there. See that push right there? And watch the second one, much more obvious in that full halo push like that. Both of those are headed our way. Again, just expected to be kind of like a flank impact, but looking pretty significant. So we got a lot of stuff. Here's this X-ray. Here's our X-ray flux for this solar flare, and we can actually see both of them here. This is over the past 6 hours right now. So just the very recent time frame. Here it is. We were hanging out at a level of, we were in, I mean, very, very low territory, just low C-class territory effectively right here. Then all of a sudden, boom, right up to 1.9 X-class flare there. And then a fairly long tail, about 2 hours. So not a super long duration flare, but you know, better than the last one. We see the last one going back right here, and we see how rapid that was up, and then also just as rapid back down. A little bit more of a tail on this one. So looking quite significant, and perhaps we even have a coronal mass ejection that's launched from it. It's a little hard to see often whether we get a coronal mass ejection from a solar flare in the first hour or two, unless it really obviously shows you a really big explosion. But we do have some chronograph imagery. We can give it a look. I'm not certain. This is a little too soon to give you a definitive statement on whether we do have a CME or not, but we can definitely give this a look and come to some conclusions, hopefully. And you'll notice there is Jupiter. It pops up in the chronograph view because it's on the far side of the sun, reflecting a lot of light back to us. Jupiter appears very bright in the night sky. It's one of the best, brightest evening stars. So we see it coming in for that superior conjunction. It appears to be moving this way because our rotation around the sun is faster. Our orbital velocity is faster than Jupiter's because we're closer to the sun. So we keep the sun fixed in position. Effectively, the Earth is rotating around the sun, and Jupiter is actually moving forward like this in relation to the sun, but from our perspective, it moves slowly like this and then has that superior conjunction, also known as a Jupiter-Cazimi. That's just in and of itself, that's a very powerful energetic moment that occurs once every 13 months or so. But we have solstice stacked on top of that. We have that grand cross, grand trine, grand kite, planetary geometry, active, heliocentric. And we also have all this solar activity and a lot of interesting things with volcanoes. We had Luatobi, and it's Luatobi Lucky Lucky volcano erupt in Indonesia twice. We have had Kilauea be very active. We've had Fuego volcano in Guatemala be very active. We just actually had some like weird shockwave like get sent out from Mount Etna in Italy. So a lot of interesting stuff right now, but let us actually do an analysis on this. You can tell that I'm excited about this. I just love the Earth stuff. I'm a geologist, geophysicist, turned into a space weatherman, spiritualist, and more. I just think all this stuff is super cool. We do see a bit of a push. I think it's a little too early to tell, but here is, again, that flare was at 2350. So this is taken right before that solar flare, okay? And then let's go forward to the next one here. This is 15 minutes later, and you'll see this jet right there pop out where it wasn't before. That's one feature. And then you will see some energy waves right there. So these plasma shock waves, see that change up there and right there, just in 15 minutes. And then this both, see how they radiate out all of a sudden? So it looks like there maybe is there's definitely some sort of shock wave radiating out, but it's not the most obvious coronal mass ejection. It's not definitely one of these big, perfect, full halo ones that tells you you have something headed right towards us. But it does look like there is a minor shock wave at a minimum coming out from this explosion. And it's just so powerful in general that you can expect that. I mean, it's not always the case, but with the next class flare, it's more often than not that you get a coronal mass ejection, though This one, we need to wait and see more data. It does look like it's mostly going to the west, but we are seeing that. Let me show you actually our sunspots right now on the sun, because these are the progenitors of course, all this activity. Without sunspots, you're not really getting these sort of solar flares. So we can see our sunspots for the past 48 hours. This is 4114. It has been decaying now. You see it kind of getting a little bit weaker, though this central core there has been getting bigger. So it's almost like a condensation effect. You actually see a lot of this flux right there. These sunspots disappear right at the very end of this video, but this big core does seem to be getting bigger throughout this entire time frame. And we have these new sunspot groups rotating in right now. There's also a pretty significant sunspot cluster looking similar to this right now on the far side of the sun, just rotated off Earth facing. Now it's about 2 days in on the far side. So we have one, it's this far side one right there, 1, 2, 3 fairly significant sunspot clusters on the sun at this moment in time. Whereas for May, we had a massive drop in sunspots. We're in solar cycle 25 maximum. You expect there to be a lot of sunspots. Our sunspot number dropped in half going from April to May. Really significant drop from about 140 for the monthly count all the way down to 79. And now we're seeing this rebound back out of that with some significant solar flares and solar storms. We had a G4 geomagnetic storm impact on June 1st. So we have had some significant solar activity over the past few weeks, and now it seems to be ramping back up again in a big way. And that June 1st impact around May 29th, that was also forecasted with planetary geometry. So we were talking about that on the channel as well. So wild stuff always. Lots of things to learn, and I think that's it for this broadcast. I don't believe there's anything else for me to discuss. We do have Kilauea soon to erupt, it looks like. This is the current USGS live stream. Right now it's smoking. This is linked in the video description. They have 3 different live streams. This is the one that has most of the viewers. And so you may want to keep an eye on this if you want to catch it live as it happens, because it looks like now, after being hit with 2 significant, powerful solar flares, that we are going to have a significant eruption at Kilauea Volcano. I wouldn't be surprised that the lava fountains are the biggest they've ever been. And of course, this is what they looked like last time. Very large lava fountains at the last eruption. Let me pull that up just one more time for you, because it was really quite incredible. Every eruption at Hawaii has been getting basically better, bigger, and better. Which is what we all hope for in life. We hope that life is only just getting bigger and better for us. So take a page out of the Sun playbook and the Hawaii playbook. That's the way to live, in my opinion. That's at least one great way to live. Thank you all for joining in on the live stream. If you like this, then please subscribe to the channel. I go over what's happening with the sun, with the earth, with the solar system, with the cosmos, and what's happening within us nearly every single day. I bring all that together, present these videos very, very often, live streams, videos, and more. I'm also on Twitter X at Stefan Burns Geo, G-E-O. So I post interim updates there. So make sure you check that out, especially now with Cosmic Summit, because I will be busy for the next couple days. If you're at Cosmic Summit, then please stop by the Earth Evolution booth. A big announcement for everyone coming out very, very soon. You'll get the first dibs on that announcement if you're at Cosmic Summit. We're actually right next to Randall Carlson. So if you happen to want to go over to his booth and talk to him, guess what? We're right across the hallway, basically. You turn from him to us, or you turn from us to him. So it's going to be really exciting, Cosmic Summit. Hoping to get a lot of amazing interviews and footage for all of you. Because I want to interview some of the different speakers there, get their thoughts on solar activity and planetary geometry, and just in general to have some symbiotic connections and interviews and connections, conversations. So really excited for that. But it is going to be difficult perhaps to manage video content for the next few days. So just keep that in mind, but I'll do my absolute best. I have the fuel tank of the sun, so I should be able to release a little bit of content during Cosmic Summit. And yeah, have a wonderful solstice, everyone. Wishing you all the best. Please take care of yourselves. Make sure you do your earthing and grounding. That really helps, especially now when there's so much volatile energy. And I'll see you all in the next video.